The next speaker is also a phenomenal person, and it's really my pleasure to introduce Pat Soranno. But first, a little perspective on what we tried to do here at JASM was we tried to think of themes that could transcend all of the societies, and we called these the plenary themed sessions. It got a little complicated, honestly, trying to name all these things. And we opted to do one on large-scale limnology, and this was really driven by John Harrison and some discussions he and I have had and some work we've done in the past, and the importance of looking at the role of lakes in multiple scales and see how they vary in spatially explicit ways, and look at the connectivity, how it may work in terms of biogeochemical cycling, organism exchange. So when we thought of who could be the keynote to address this or launch us into this plenary theme, we thought of Pat Soranno unconditionally. So Pat Soranno defines herself as a landscape, oh wait, I should do the other little kind of stuff. Okay, so Pat is currently a professor at the Department of Fisheries and Wildlife, at Michigan State University. And she did her bachelor's at Notre Dame and her MSc and PhD at the University of Wisconsin-Madison. And Jim Elser, our incoming ASLO president, wanted to say that one of the best decisions of his life was to give Pat Soranno a job in the mid-'80s. So he wanted me to say that, and I wanted to say that. This is just a great example of creativity launching more creativity. So always give people those wonderful opportunities. So Pat has a beautiful career and a beautiful career coming, because she's very young, and has published extensively on landscape limnology. And what I'm going to do is I'm just going to read how she defines it on her website, because there's lots of wonderful, generous information on what she does and the different approaches she uses that demonstrates her generosity. And I think it's a perfect candidate for this meeting in reading this. So she defines landscape limnology is the spatially explicit study of lakes, streams, and wetlands as they interact with freshwater, terrestrial, and human landscapes to determine the effects of patterns on ecosystem processes across temporal and spatial scales. So I think this is a really fitting person for this meeting, and I'd like you to welcome Pat to the stage.
Thank you. It's wonderful to be here, and really what's most special about this is the fact that there are lake, stream, and wetlands people in the audience. And I certainly, for one, wish we did this every year, but Lucinda tells me that would be quite challenging. So I thank the organizing committee for making this great conference happen. So I'd also like to thank Jim Elser for giving me my first job. My first job was dissecting Chaabris guts and identifying the contents, and that is doing that not knowing what zooplankton looked like. So that was a little challenging, but despite that, it was a great job, and here I am. So I'm going to start by turning the slides off. I don't have anything to show you quite yet, and I would like you to do a little work for me right now. So stand up straight and wake up a little bit. What I want you to do is think about freshwater science for the last 50 or 60 years or so, and imagine a gradient in your mind from very fine scale to very broad scale. So we're talking spatial scales. And if you had to draw a histogram of what the majority of freshwater studies were conducted at, what scale? So think about that a moment, do it in your mind. What I'm hoping is that most of you are thinking of some sort of normal distribution, and I think where that normal distribution is on the spatial scale, we probably would argue about, and I've argued about with many colleagues, but I'm thinking the distribution will be about the same, and that at the very micro scale and at the very macro scale, we have not studied as much as we have more intermediate scales. And that's what I want to talk about today. The micro scale and the macro scale seems to be emerging right now as important areas for study for freshwater and actually aquatic sciences in general. Those of you that saw the talk yesterday, Ginger's talk about the advances at the micro scale using genomics, which are really helping us rethink the way we think about the microbial community in oceans. Today I'd like to talk about the macro scale. Now, what I find really interesting, though, is that these two opposite ends of the scale spectrum actually have something really important in common, and that's very large data sets and large data streams. And so I think it's a pretty cool thing to think about, that both of these, with seemingly pretty different ends of the spectrum, are in fact quite similar from that standpoint. And Ginger did talk about some data-intensive work in the area that she does. So today, I would like to start off by talking about big data. And I'd like to start by talking about the big data is great era, from approximately 2008 to 2012. And I would imagine most of you have seen at least one of the covers of these, both science and popular periodicals. And one thing to note, if you write articles about big data, you have to use really big font. So that will become important later as well. So the other thing you should be thinking about, you should be rolling your eyes and saying, oh my gosh, I'm so tired of hearing about big data. It is such a bandwagon. And yes, it is. But fortunately, the wheels are starting to fall off, and we are now entering the era of big data is not so great. And this is a very recent era, started just about last fall, really. And continuing with the idea that you've got to use really big font, here's an article of why big data is bad for science. And so this is one of the more important ones, but also other sectors from business and society, big data, are we making a big mistake? And 8, no 9 problems with big data. So this makes sense. All bandwagons eventually get sort of a backlash. And what concerns me a little bit about this is if scientists actually take this to heart too soon, or sooner than we should. Now, if you read these articles, and I'm sure they're going to continue well into this year and the future, I think a lot of the criticisms can be broken down to these major categories. So first of all, big data is atheoretical. It's only data-driven. It's biased because we're sometimes compiling lots of different data sources. There's the multiple comparison problem where everything comes out significant. We have expertise missing in being able to really analyze the data, the large data streams, and there's issues with using other people's data. Okay, so this seems like there's problems, and maybe we should be careful in thinking about using big data. But unfortunately for freshwaters, I think we need to consider and we need to use big data because there are many problems, and many people have talked at the conference so far about issues that cross broad geographic extents. And so if we're trying to understand how how freshwaters are going to change in light of land use change, climate change, and other global change, then we need to understand sort of broader scale phenomena related to freshwaters. So this brings me to the therefore, and thanks, Dan, for mentioning the reference to Randy Olson. So we've got freshwater problems that require a big data approach across broad spatial scales, but big data has its problems. So therefore, the main thesis of my talk today is that we can use big data approaches, and I think we should, to study freshwaters at broad scales, but that I think there's 3 conditions that if they're met, we will successfully address all of the concerns that are already being thrown at big data. So the first is we need to take an interdisciplinary team science approach. We need a strong conceptual foundation guiding the research, and we need robust quantitative methods. Okay, so that's the overview of my talk, and really you can now stop thinking and go back to sleep. All right, so why do we want to do this? What's so great about conducting freshwater research at broad scales? Well, I think it's pretty useful because when you think about what we want to do as ecologists, often we exist in a data-poor environment. So we may study some systems really well, but we want to be able to extrapolate to systems for which we don't have data. The next thing we want to do is we often want to scale up our rich, fine-scaled knowledge from local scales up to the region, to the continent, and to the globe. And of course, scaling up the contribution of freshwaters to global carbon cycles is a great example of that. And finally, we also want to be able to forecast how ecosystems are going to change. Now, to me, this sort of sums up our goal of ecology as a whole of what we want to do. And I don't think big data is going to allow us to completely do all of this, but I think it's going to get us well on the road to being able to do this a little bit better than we're able to now. All right, so fortunately, we do have some conceptual foundations to guide us. I'd like to mention an emerging area of study in the broader field of ecology called macrosystems ecology. And I'm going to read off this definition for you. Macrosystems ecology is the study of diverse ecological phenomena at the scale of regions to continents and their interactions with other phenomena at other scales. And I really have to acknowledge Jim Heffernan, who I co-led an effort with 15 other scientists to come up with this definition. And this definition took 2 years to write. And so when you think about how many characters per month that took, it was pretty phenomenal. But Jim was great to work with in this. And actually, it was great that we had 17 total co-authors to come up with this definition, because I think it's better for it. So I also want to, and this is a shameless plug for this special issue where the whole topic is on macrosystems ecology, but I wanted to mention something to this audience, because there were 5 papers in this special issue from contributions of research groups already doing macrosystems ecology. And what's really interesting is there's a paper about streams in there, there's a paper about wetlands, and there's a paper about lakes with specific aspects studying macrosystems ecology. So what this means is that freshwater scientists are poised to start studying ecological systems at these broad scales and become leaders in this emerging area of macrosystems ecology. So give yourselves a pat on the back. All right, before I go any farther, I have to talk about definitions because actually I don't like the term big data, but it's sort of a good way to introduce the topic. Here's the standard definition of big data that a lot of people have talked about already. But what I'd like to do is argue that we really should be using the term data intensive. Big data is a problem because what's big today is not going to be big 10 years from now. Data-driven phrase is a problem because that implies it's atheoretical and there's no conceptual foundation. And finally, data-intensive makes the most sense to me, and others have argued for this term as well. And just to give you a little background, really the seminal work on data-intensive science in general is perceived to be this book, The Fourth Paradigm, edited by Tony Hay, who's at Microsoft. And the idea here is that looking through the history of science, that we've entered an era of a new paradigm of the way of doing science. And so, you know, we've gone from empirical, theoretical, computation, and data intensive now. And the modes that ecologists do research don't completely map onto this, but they do to some degree. And you can debate whether we're in a new era or not. But regardless, this book has a lot of really interesting ideas to think about how we can do science in a data-intensive era. I also would like to point out that ecologists have the benefit that we've got a lot of history working with fairly large data sets through comparative ecology and comparative limnology with which to ground a lot of this research into larger and larger data sets. All right, so I'd like to now move and talk about ecology specifically and talk a little bit about ecology's relationship with data. Throughout